Hello everyone. Welcome back to our channel. Today we're going to solve an exponential system, as shown on the screen, and find the real value of x plus y. At first glance it looks messy, but there's a beautiful symmetry hidden underneath. Using two different approaches, a logarithmic method and a clever multiplication trick, we'll see how the entire system collapses into a simple expression in terms of x plus y. Let's walk through it step by step. The first approach is to use a logarithmic method. Step 1. Take natural logarithms. Whenever exponents appear in multiple places, logarithms are one of the best tools we have. So let's apply natural logs to both equations. From the first equation, using the logarithm product and power rules, we got its new equation as shown on the screen. Similarly, from the second equation, we got its new equation as displayed on the screen. Now we have turned a nonlinear system into a linear one. Step 2. Rewrite everything using common components. To make the structure looking clear, let's introduce two constant variables, a and b. We have log 4 equal to 2b. Let's rewrite the right-hand sides too. Thus, both log 24 and log 72 can be expressed in terms of the constants a and b. Now substitute everything into the equations. We got the new equation as shown on the screen. These two equations look almost identical, just with x and y swapped. That symmetry is the heart of the first method. Step 3. Add the two equations. Add the left sides of the equations together, and do the same with the right sides. We got the new equation as displayed on the screen. By factoring both sides, the magic happens, everything collapses neatly into just x plus y. Since a plus 2b is not equal to 0, we divide both sides and got the entire solution. X plus y is equal to 3. In the second method, we skip logarithms entirely. Instead, we use a clever trick that takes advantage of the symmetry in the equations. Let's take a look. Step 1. Look at the structure. Notice these equations look almost identical. The first has 3 to the power of x with 4 to the power of y. The second has 3 to the power of y with 4 to the power of x. Whenever you see expressions where the variables swap positions, it's worth trying multiplication. Step 2. Multiply left sides and right sides. Multiply the two equations together, left side with left side, and right side with right side. The left side simplifies beautifully, as shown on the screen. The entire expression becomes 12 to the power of x plus y. This is the key collapse. Both exponents now combine into a single term, x plus y. Step 3. Simplify the right side. Reorganize and simplify the right side. We find that the right side equals 12 to the power of 3. So our equation becomes 12 to the power of x plus y is equally to 12 to the power of 3. Now the exponents are directly comparable. Therefore, x plus y is equal to 3. That's the solution. No logs, no systems, and barely any algebra. Why do both methods work so well for solving this problem? What are the key insights behind them? For the first method, after taking logarithms, the two equations share the same structure, just with the variables swapped. Whenever you see symmetric linear equations, adding or subtracting them often isolates x plus y or x minus y. This method demonstrates a powerful general technique. Use logarithms to turn exponents into linear terms, then exploit symmetry to collapse the system. The key insights in the second method come from 3 observations. Number 1. The equations have a mirror-like structure, x and y trade places. Number 2. Multiplying the equations makes the exponents add, instead of interacting separately. Number 3. Both sides collapse to the same base, allowing us to compare exponents directly. This is a classic trick for solving symmetric exponential systems. We've created a 1-minute video that explains the two key insights in detail. If you're not interested, feel free to skip it. Otherwise, let's start the video. In summary, the first method teaches a powerful general technique. Use logarithms to turn exponents into linear terms, then exploit symmetry to collapse the system. Even though the original problem looks complicated, the hidden symmetry makes the solution surprisingly clean. The second method uses a classic trick from symmetric exponential systems. It's extremely powerful because it reveals the structure hidden inside the problem, allowing everything to simplify instantly. Both approaches, logarithmic linearization and symmetry-based multiplication, lead to the same elegant result x plus y equals 3. Look for this kind of symmetry in your next exponential puzzle. Alright, it's time to wrap up. What do you think about the problem, the solution, and the key insights? Leave a comment below, and don't forget to like, share, and subscribe for more fun math problems. See you next time, and thank you for watching.